artillery has become one of the decisive arms on the modern battlefield. This video ordnance program will examine the artillery weapons of the U.S. Army, why artillery has come to play so important a role in modern warfare. Artillery changed little in its first 5 centuries of existence, from the introduction of gunpowder from China through the classic cannon of the American Civil War we see here. Early cannon worked on the same basic principle. Gunpowder was loaded through the cannon's front bore and packed into the base of the cannon's tube, followed by the projectile. The routine for cannoneers followed much the same pattern as we see here with this American Civil War era bore-loaded cannon. Cannon were basically direct fire weapons. They could only fire accurately on targets they could actually see.
Ready!
The technology of artillery began to change in the latter half of the 19th century with the advent of propellants more powerful than gunpowder, new high explosives for the projectile, and new stronger steels for the gun tube. Artillery entered the industrial age with the substitution of breech loading for bore loading. New mechanisms permitted the cannoneer to load through a new rear breech mechanism, greatly speeding the process of loading and firing. These new cannon completely altered the nature of land warfare in World War I. Cannon could now fire 15 miles or more beyond the view of their gunners. Suddenly, the areas behind the battlefield became nearly as deadly as the battle line itself, and the new rapid-fire cannon could devastate with far more fire than old breech-loading cannon. These 3 revolutionary changes in cannon, range, rate of fire, and explosive power, meant that artillery dominated the World War I battlefield. World War II saw the emergence of the armored vehicle as an antidote to the artillery revolution. The armored vehicle could protect its crew from artillery's deadly firepower. In some respects, the tank absorbed the artillery's direct fire role. Like the Civil War cannon, the tank gun was used against targets that could be seen by the crew. The technological evolution of the artillery as an indirect fire weapon continued. Most artillery crews never saw their target, relying on mathematical formulas and geometrical calculations to accurately fire their weapons against distant targets. But artillery remained the most destructive force in land warfare, accounting for about 70% of all battle casualties. Artillery was improved and modernized. Artillery weapons were mounted on tracked armored vehicles to enable them to keep up with the other armored vehicles of the tank division. Artillery can be categorized into 3 basic types related to the flight paths of their projectiles: mortars, howitzers, and guns. These days, mortars are mainly used as the pocket artillery for the infantry, lightweight and easily moved. Howitzers are the most common weapon of the regular artillery, varying considerably in size and appearance. The 2 basic categories of howitzers are the traditional towed howitzers and the self-propelled howitzers. Artillery weapons are further described by their bore diameter, the inner diameter of their gun tube. This is a 155 millimeter howitzer, meaning that its gun tube is 155 millimeters across, or about 6 inches. The range of a modern cannon is determined largely by the amount of propellant used to propel the projectile and the length of the gun tube. Some smaller howitzers, like these lightweight 105 millimeter howitzers, use a metal case behind the projectile to contain the propellant. The larger howitzers do not use a metal casing for the propellant, using simple bag charges instead. This allows the howitzer crew to vary the amount of propellant loaded into the cannon. Fewer bags for shorter range, more bag charges for greater range. Barrel length also affects range. The longer the howitzer barrel, the more time the propellant has to propel the projectile forward. Longer barreled howitzers have greater range than shorter barrel types. The configuration of howitzers is shaped by their mission. Towed howitzers are the most traditional form of artillery. The smaller 105 millimeter howitzers are a favorite of light mobile divisions such as paratroop and helicopter forces. The 105 millimeter gun is light enough to be airlifted by helicopter. This is the delivery method favored by units like the 101st Air Assault Division. Other light units, such as the U.S. Army's light infantry divisions, use the Humvee to tow them into combat. The 105 millimeter howitzer can also be airdropped by parachute. This is the delivery method favored by the 82nd Airborne Division. Larger towed howitzers, like this M198, are found in Marine divisions. The towed 155 millimeter howitzer is much lighter than the self-propelled 155 millimeter howitzer. This is an important consideration for Marine divisions, which must move all their equipment by ship and amphibious landing craft. The backbone of today's artillery force is the self-propelled howitzer. They are most commonly found in the Army's armored and mechanized infantry divisions. Self-propelled artillery is needed in maneuver divisions to allow the artillery to keep pace with the tanks and infantry vehicles in mobile operation. The U.S. Army has favored tracked self-propelled howitzers, since they have the best performance in tough conditions such as mud or snow. Some armies, which operate in dry or flat terrain, such as the South African Army, the howitzer is mounted on a wheeled chassis, you see here. The use of a mobile chassis allows some self-propelled guns to carry armor protection for their crews. A self-propelled howitzer looks much like a tank, but there are important differences. The self-propelled howitzer is not heavily armored like a tank, only enough armor to protect it against shell fragments from enemy artillery. Self-propelled artillery vehicles usually have their turrets mounted on the rear of the chassis, while a tank has them in the center. Mounting the turret in the rear of the vehicle makes it easier for the ammunition handlers to pass the ammunition to the gun crew. There are two elements of an M109 howitzer crew: the crew inside the vehicle, who aim and fire the cannon, and the loaders outside the vehicle, who handle the ammunition.
You would have approximately 4 personnel inside of the howitzer when the weapon is being fired. You would have the gunner. He aligns the howitzer on the azimuth of fire given by the Fire Direction Center. You have the assistant gunner, who is an E4 or corporal. He elevates or depresses the tube to the appropriate quadrant given by the FDC. You have the chief of section, who initiates all of the commands to the individual howitzer crews. You have a number 1 man who loads and fires the howitzer when commanded by the Fire Direction Center. And you have the number 2 man who does the recording of the fire mission itself.
In recent years, a new vehicle called the FASV has been developed for the artillery. The FASV is an armored ammunition handling vehicle. In the past, ammunition for the M109 was brought forward by unarmored vehicles, which were vulnerable to enemy fire. The new FASV better protects the ammunition and has handling equipment inside, such as a conveyor belt, to speed the loading of the M109 howitzer. One of the most significant technological revolutions in artillery has been the advent of new positioning equipment. The accuracy of artillery is very dependent on knowing precisely where the artillery is located in relationship to the enemy target. In the past, this was done by laborious and time-consuming surveys. Newer systems, like the improved M109 Alpha 6 Paladin, contain their own positioning systems.
This howitzer that you see directly behind you is the M109 Alpha 3. And in fact, some of these howitzers that you see here were actually in Saudi Arabia in the Iraq War, although they've been repainted. The Paladin howitzer is an improvement over this in several ways. The biggest thing is that it allows each howitzer to carry with it directional, well actually a location finding capability, so that the howitzer knows where it is at any given time period. What that allows a battery to be able to do is, instead of having howitzers on line the way that we do today, we can have howitzers in different locations, and they can still fire from those locations and still all fire at one time and hit the same target. That increases survivability immensely on the battlefield. In this kind of configuration, if you're in the battlefield and we fire rounds from this location and the enemy picks up by radar or some other means where we're located at, they will send counter battery fire on top of us. Therefore, we can only stay in one location and fire so many missions before we have to move. With the new Paladin system, you will be able to go out with pairs of howitzers or a few howitzers, almost like armor tactics with tanks, and they will not have to be in a given gun line the way we do business today and be laid along the same azimuth, because a lot of that data will be carried on the howitzer itself.
The revolution in positioning systems has been matched by revolutions in the projectiles fired by artillery. One of the most important new types of ammunition is called DPICM. Normal projectiles are filled with a load of high explosive. DPICM is filled with small grenades. A high explosive projectile can devastate a single target, while DPICM covers a much wider area. During Operation Desert Storm, the DPICM projectiles were called Steel Rain by the Iraqi troops.
The high explosive round can do a couple of things. It can either detonate upon impact, or we can have it detonate in the air where it explodes from within, spraying shrapnel in a given location. But the devastation and the destruction of the dual-purpose improved conventional munition is almost beyond belief without actually experiencing it falling on you. The devastation that occurs on equipment and other things when those shape charges goes off is almost intolerable to try to survive under a barrage of DPICM. That is the munition of choice on the battlefield. When we were in Iraq, we captured some POWs during the war, and we had one of the leaders of a group of POWs come up to us and talk about the rain of artillery. And one of the statements that he made was, no more rain artillery, no more rain artillery. And they were speaking primarily of the devastation that they had experienced under the fires of DPICM.
Artillery has traditionally been an area attack weapon, best suited to bombarding a large area with a barrage of high explosive. In recent years, laser technology has permitted the development of projectiles such as copperhead, which can hit pinpoint targets. To guide a copperhead round, a laser designator team is needed who can see the target. U.S. Army artillery forward observers in the Fist V vehicle can perform this function. In the hammerhead mount over the vehicle is a laser designator which shoots a beam of laser light at the target. As soon as they are ready to laze the target, the artillery system, 10 miles or more behind them, is instructed to fire the copperhead round into the approximate vicinity of the target. The copperhead round can detect the laser light being reflected off the target.
What it is, it's a round that gets loaded into the tube and fired. And once it's fired, some fins pop out that stabilize it in flight. And someone on the ground near the target location at a given time lasers with a laser designated device, or maybe a plane or some platform from the air lasers a target. And as the round comes into the near vicinity, if it's in the proper footprint for the trajectory, the round will home in on that laser. And as it homes in on that laser, it can actually achieve pinpoint accuracy, as you talk about, and blow up an individual item of equipment, almost like what you would have in direct fire, where a tank sees something, it fires on it, and it blows another tank up. We have that capability with the copperhead munition. The copperhead munition, though, is not something that we fire huge amounts of copperhead out onto the battlefield and everybody's lasing at one time and individual vehicles start blowing up. It's more of an artillery sniper weapon where we would take out what we call a high priority target, maybe some sort of a higher level command and control node, or something that would be very important to a higher level commander, something that they might need taken out.
Although the M109 is the most numerous howitzer in the U.S. Army, a second type, the M110, is also in service. The M110 is a 203mm howitzer which provides heavier firepower. It can fire normal ammunition 12 miles and rocket-assisted ammunition up to 18 miles. The projectile fired by the M110 is about double the weight of the M109's.
We can reach 30 kilometers with our rocket-assisted projectile. It's the maneuver commander's general support artillery weapon. Each projectile weighs right around 200 to 208 pounds, depending on the type of projectile we fire. Our crews normally run about 10 men in a chief of section. It can be safely fired with 8 men in a chief of section. We have 10. Each man is responsible. You have a man that's responsible for driving. You have a man responsible for preparing the projectile, a man responsible for fusing, loaders. You have a gunner, an AG, and all of these gentlemen work together in a concerted effort. We call it orchestrating the effort on the gun deck.
In order to put its devastating firepower onto a target, modern artillery requires an extraordinary degree of coordination. Artillery is called a system of systems. 3 elements are especially important. The howitzers and other weapon systems are the artillery's muscle. The Fire Direction Center, or FDC, is the brains of the artillery, coordinating the actions of scattered artillery batteries. And finally, artillery radars and forward observers serve as the eyes of the artillery. For the artillery to deliver its fearsome firepower accurately, all these systems must act in unison with one another.
There are other aspects of artillery that the average layperson wouldn't understand. For example, we have to have good position data. We have to have good directional data, and our survey teams do that for us. We also have the people that have to maintain the artillery systems, our mechanics, and that's a very large aspect of our job. We have to have meteorological data, weather data, that enables us to know what's going on in the environment that the projectile is flying through, and we have metro systems that do that. We have target acquisition capabilities such as our radar systems, and they're a very important part of the artillery total systems approach to getting our job done.
The basic unit of the artillery is a platoon consisting of 4 howitzers. Coordinating this platoon is a fire direction center located nearby.
Basically, in artillery, what you have is the guns are the muscle, and the fire direction center is the brains. And each individual piece has to be given data to be able to determine from where they are, left and right and up and down, what they have to fire to able to throw around a certain amount downrange to hit a given target. What we have is, for each group of 4 howitzers, we have what we call a fire direction center. It's housed in a track that's a 577, and there's a computer system in this track. That computer system computes the data for each individual gun, and that data is sent digitally from the computer down to each gun, and then each gun individually goes left to right and up and down their deflections and quadrants to what they're going to fire on a given mission.
Range 4550.
For the fire direction center to provide accurate pointing and aiming instruction to the howitzers, information on the enemy's position is vital. Target data can be gathered from a wide range of sources. The location of the enemy artillery is determined by the firefinder radars. These radars track the flight path of incoming enemy artillery and then calculate the location of the enemy howitzer or mortar. During Desert Storm, the radars were able to determine this information so quickly that the U.S. artillery could open fire on Iraqi artillery positions even before the Iraqi artillery projectiles had landed. For targets nearer the battle line, fire support teams provide the key data. These forward observer teams can be on foot, but in maneuver units, they usually go into battle inside the Fist V vehicle.
The Fist V is the fire support vehicle that we use. That houses the eyes of the artillery. The fire support officers who travel with the mechanized division, the armored division. It has a laser system that enables them to spot the target, determine a bearing, a direction to that target, and then a range to that target. It gives us greater accuracy. It gives us greater mobility. The communication systems that are inherent to that system give us a better command control capability with that system. And those are the major things that we gain from it.
It is the coordinated action of the fire direction centers, the target acquisition systems, and the artillery batteries themselves that makes modern artillery so formidable a weapon on the modern battlefield. Rocket artillery is as old as gunpowder itself. There was a revival in the use of rockets for artillery during World War II. This German multiple rocket launcher is a forerunner of today's rocket artillery system. One of the stars of the U.S. artillery during Operation Desert Storm was the NLRS.
One of the vast improvements that we've gained through MLRS is the massive amount of firepower that's available, the terminal effects firepower that's available to that one vehicle, one M270 launcher that the American public saw on television during Desert Storm equates to roughly 1 battalion equivalent of tube artillery. Now, when you have that kind of firepower available to you and the maneuver that that vehicle has inherent in itself, and its survivability capability of being able to shoot and leave and then not have to worry about the terminal effects of any enemy systems firing on it, that's a vast improvement in our capability.
The new U.S. Army rocket artillery system is called MLRS for Multiple Launch Rocket System. Each MLRS launcher is equipped with 12 rockets. The rockets are armed with 644 submunition grenades, much like the cannon artillery's DPICM system. A single rocket from an MLRS can devastate an area the size of a football field. The MLRS was the first U.S. Army artillery system to take full advantage of the revolution in navigation systems. Each MLRS launcher has its own onboard navigation system. At the beginning of the mission, the MLRS crew drives up to a pre-surveyed spot where it obtains its location data. From that point on, the navigation system keeps precise track of where the vehicle is located. When target data is received by the MLRS launcher from the Fire Direction Center, it is inputted into the vehicle computer. The computer then analyzes the target data and its own location data, resulting in a solution to automatically aim the launcher at its target. The MLRS has been designed to operate with a minimum of personnel. There are only 3 men in an MLRS crew compared to 11 on an M110 howitzer. The loading of large rockets has been simplified by automation.
The system is fairly easy to load. After you're done with the fire mission, you go to a load supply point. What you do is rotate the LLM. You have a menu inside that tells you where you want to position the LLM. You would download your expended pods, move your LLM onto the ammunition. You hook it up and you just lift it up. Then you put your booms back in, press stow, and the system automatically go to the stow position, and you're ready to hit the firing point and shoot again.
Artillery is one of the oldest and most traditional weapons of land warfare. As simple as the basic weapon may seem, subtle new changes in computers, navigation systems, radars, and ordnance have ensured the central role that artillery plays on the modern battlefield. Technology has revolutionized the firepower of the artillery strike.